The Western Rhode Rivers are two subestuaries of the Chesapeake Bay, which contain approximately 53 million cubic meters of water. The watershed covers 78 square kilometers and has an average depth of 2 meters. Freshwater flows into the Chesapeake Bay primarily from the Susquehanna River and is mixed with salt water flowing up from the Atlantic. The WRR subestuaries undergo constant fluctuations in the environmental conditions such as salinity, dissolved oxygen, sediment, and nutrient concentrations. The excess nutrients entering the Western Rhode Rivers have over time caused what is known as a eutrophication process. In the eutrophication process, excess nutrient flow causes algae to overpopulate the waters. The excessive algae growth clouds the water, and thus subaquatic vegetation on the riverbed doesn't receive sufficient sunlight to sustain life. This water clarity, also known as Secchi depth, is used as one of the main indicators of the water quality in the WRR. The algae in the rivers eventually die off, which may seem like a good thing, but in fact this algae die-off harms the rivers even more because they oxidize, thus reducing the dissolved oxygen levels of the water and further preventing subaquatic vegetation growth. Shown below is the 2011 West Rhode Riverkeeper report card, in which you can see the water clarity, dissolved oxygen, nutrients, chlorophyll, and subaquatic vegetation as they meet or do not meet the threshold and their grade average for that year. The West Rhode Riverkeeper Incorporated is a nonprofit organization established in 2005 with the mission to reduce pollution, enforce environmental laws, and promote restoration in the Western Rhode Rivers. The organization is funded through grants and the community through fundraisers and donations.
I'm Chris Trumbauer, and I run the West Rhode Riverkeeper organization, and my title is also Riverkeeper. So we're a nonprofit organization, and we really exist to stop pollution from going into the Western Rhode Rivers. We're here in Anne Arundel County in Maryland. We work with the community, try and do restoration projects, do outreach, we do water quality monitoring, and we advocate for a better environmental policy.
The local Maryland watermen are citizens who make a living from fishing and harvesting fish, crab, and oysters from the Chesapeake Bay and its tributaries. Once a prosperous industry, currently Maryland has seen a decline in working watermen due to overharvesting and environmental changes. As excess nutrients and sediment run off into the Chesapeake Bay, aquatic species have been affected by an ecological decline in the subaquatic vegetation. In response to this change, watermen require new methods to continue earning an income from the Chesapeake Bay. The Maryland Department of Natural Resources governs the Chesapeake Bay and its tributaries, as well as manages the coastal regions. In addition to regulating the use of waters, the MDDNR also promotes and supports the aquaculture enterprise. Through providing leases and loans for local watermen, the MDDNR plays an active role in sustaining the profitability of aquatic harvesting in Maryland. The objective of the MDDNR is to regulate Chesapeake waterways, as well as support the aquaculture industry. The residents surrounding the Western Rhode Rivers support the restoration and protection of the water. However, they also contribute excess runoff through yard and stormwater drainage. Construction sites, fuel stations, and boating communities also contribute to this nutrient runoff and sediment erosion. With the creation of the West Rhode Riverkeeper Incorporated, these negative impacts have been measured and solutions to reducing environmental impact have been publicized over the past decade. Due to the reduced filtering which occurs for bottom-feeding oysters, a vertical cage system will be used in order to maximize filtration. The cage system will be based on a previous study and allow for optimal oyster filtration rates. The cages will be anchored to the river bottom with deadweight anchors and lifted with trawl floats. The cages will consist of triple-stacked trays capable of holding 3,000 market-size oysters each. Due to leasing and permit constraints, the proposed site, shown here, will be placed in the Rhode River, whereas the West River will be used as a control for the project considering the amount of leases already in place. The proposed site location, at a maximum capacity, can hold 5 lines per acre, 750 trays per acre, and 2.25 million market-size oysters per acre. The first alternative, remote setting, is a land-based operation requiring large tanks with cages to hold the shell to which the oysters will attach. The process takes approximately 10 days before the oysters can be placed in the water. The second alternative, nursery, requires buckets and floating upwelling systems for initial growth. The seed is placed in the buckets with microculch or crushed shell. The seed then each attaches to each piece of culch. This process requires approximately 21 days until the oysters are ready to be placed in the water. The third alternative, spat on shell, comes from the hatchery and are ready to immediately be placed in the water. In addition to these methods of grow-out alternatives, oysters can also be sold as half-shelled or shucked oysters. The method of analysis, shown below, includes evaluating the growth and survivability of the three alternatives for obtaining the oysters in the growth model. It then evaluates the amount of nutrients filtered with the two-dimensional tidal mixing model, while also evaluating the financial feasibility using a business model. Next, the design alternatives will be evaluated by a utility function, and finally the alternatives will be evaluated based on the cost versus benefit analysis. The purpose of the growth model is to evaluate the probability of having oysters reach market size, 3 inches in Maryland, within varying amounts of years, up to a total duration of 5 years. This length was chosen because the loan for the initial shell and oysters can be applied for 5 years. This probability is evaluated through the calculation of oyster biomass over time. The biomass is dependent on the environmental conditions of the Western Rhode rivers in order to grow, as well as biometric variables of the oyster. The purpose of the two-dimensional tidal mixing model is to determine which amount of oysters will filter the largest percentage of nutrients based on the least location suggested in the system design. The model that was developed for last year's method of analysis will be adapted this year in order to measure the filtration rate of the eastern oyster after the biomass has been calculated in the growth model. The initial conditions for the nutrient load, tidal flow, and oyster biomass will be used to run the model, which will then be input into 9 cells that represent the separate segments of the Western Rhode River. The business model calculates the yearly cash flows from the probability of profit in yearly increments. The inputs to the business model include the output from the growth model, costs of oyster operations, selling price of oysters, the amount of time the model will run, and the demand for oysters. The growth model output indicates a 79% chance of market-size oysters within 3 years in the Western Rhode rivers. This simulation was run for 10,000 iterations in order to ensure a confidence interval of 95%. The two-dimensional tidal mixing model indicates that maximum oyster filtration rates are achieved with a 10 million oyster aquaculture system. This simulation was run at both 1 million oyster capacity and 10 million oyster capacity. The business model output indicates the highest ROI gain occurring at approximately 5 million oyster operating capacity. The economy of scale is gradually diminished after this point. Shown here is a utility diagram versus the cost of each alternative. Remote setting has the highest utility output, followed by nursery and then spat on shell, all sold at half shell. The alternatives are the same for shucked. Remote setting has the highest ROI at all levels of cost. However, if public approval decreases 2% or more, or if availability of shell increases 5% or more, the nursery alternative has the highest utility at all costs. If public approval increases to 40% or more, then spat on shell has the highest utility. Based on these results, it is recommended a remote setting stage oyster aquaculture system be implemented in the Western Rhode rivers to increase the water quality while providing a financially self-sustaining business for local watermen if sold at half shell.
Great. I think it's the 4th year of our partnership, and we've successively been getting more and more focused on actual tangible outcomes, and this was good because I think it represents a model that we can pursue, work with the community, work with some of the folks at state agencies to see, is this a viable thing that the waterman community can do to not only make some money for them, but also do something positive for the water quality. The oyster fishery around here is at historic low levels, 1% by most estimates of what it was in the boom times. And there's still watermen out there that are making their living doing that. There's just not that many oysters around. So anything that we can do to try and promote that population to grow and be economically viable for the watermen, but also environmentally positive and help take some of the nutrients and sediment out of the water is something that we're totally on board with.